In the long history of human exploration, the moon has always been more than just a glowing object in the night sky. It has been a symbol of mystery, a target of ambition, and a silent witness to every era of civilization. But 2026 stands out in a way that no previous year has before. It is shaping up to be a turning point, not just for space agencies, but for the future of humanity beyond Earth. What makes 2026 so important is not a single event, but a convergence of missions, technologies, and global competition that all point toward one destination: a permanent human presence on the moon. For the first time since the early lunar landings of the 20th century, the moon is no longer just a place to visit. It is becoming a place to stay, to build, and to use as a foundation for deeper space exploration. One of the biggest reasons 2026 matters is the acceleration of lunar missions focused on infrastructure. Instead of short visits, space programs are now preparing systems designed to last. These include orbital stations around the moon, surface habitats, and robotic networks that can operate independently. The moon is being treated like a testbed for survival beyond Earth, where every system from energy to communication must work without immediate support from home. Another critical development is the renewed interest in lunar resources. The moon is believed to contain valuable materials, such as water ice trapped in permanently shadowed craters. This water can be broken down into oxygen and hydrogen, creating breathable air and rocket fuel. If this process becomes reliable in 2026 missions, it will completely change the economics of space travel. Instead of launching everything from Earth, future missions could refuel directly from the moon, making deep space exploration far more practical and less expensive. At the same time, technology is reaching a level where long-term lunar living is no longer science fiction. Advances in robotics, artificial intelligence, and autonomous construction are allowing machines to build before humans even arrive. Imagine habitats printed from lunar soil, power systems that adapt to extreme temperature shifts, and AI systems managing life support without constant human input. These ideas are moving from theory to real-world testing, and 2026 is expected to be a major proving ground. Shift from exploration to settlement. 2026 marks a major turning point where the moon is no longer just visited, but prepared for long-term human presence and infrastructure development. 2026 is becoming a defining moment in human space exploration because it marks a clear shift from short lunar visits to long-term planning for human presence on the moon. For decades, missions to the moon were brief scientific achievements, but now the focus is changing toward building systems that can survive and operate for extended periods. This includes the development of lunar habitats, orbital platforms, and automated robotic systems that prepare the surface before astronauts arrive. The goal is no longer just to land and return, but to establish a lasting foothold that can support future missions deeper into space. This transformation represents a major evolution in how humanity views the moon, not as a distant object to study occasionally, but as a strategic extension of Earth's activity. The year 2026 is especially important because many planned missions and technologies are expected to be tested together for the first time on a large scale. If successful, they will lay the foundation for continuous lunar operations. This shift also reflects a broader change in human ambition, where space is increasingly seen as a place to live and work rather than only explore. In this way, 2026 may be remembered as the year when the moon truly became part of humanity's future. Rise of lunar infrastructure mission space programs are focusing on building habitats, orbital stations, and robotic systems designed for sustained operations around the moon. One of the most important reasons 2026 stands out in lunar exploration is the growing focus on using the moon's natural resources, especially water ice. Scientists believe that large amounts of frozen water exist in permanently shadowed craters near the lunar poles. If this water can be successfully extracted and processed, it can be split into hydrogen and oxygen, which are essential for rocket fuel and life support system. This means future missions would not need to carry all their fuel from Earth, dramatically reducing costs and increasing the efficiency of deep space travel. The moon could become a kind of refueling station for missions heading toward Mars and beyond. In 2026, several planned missions are expected to test the technologies needed for drilling, extracting, and processing these resources directly on the lunar surface. This is a critical step because it moves space exploration from a fully Earth-dependent system to one that can partially sustain itself beyond our planet. If these tests succeed, they will open the door to a new space economy where the moon plays a central role in supporting exploration, industry, and scientific research. This development is not just about technology, but about changing the entire way humanity travels and operates in space. Lunar resources and fuel potential discovering and using water ice on the moon could allow production of oxygen and rocket fuel, making future space missions cheaper and more practical. Another major reason 2026 is considered a turning point for lunar exploration is the rapid advancement of autonomous technology, especially robotics and artificial intelligence, which are becoming essential for building and operating systems on the moon. Because the lunar environment is extremely harsh, with dangerous radiation, extreme temperature changes, and long periods without sunlight, humans alone cannot handle every task directly. Instead, intelligent machines are being developed to take the lead in construction and maintenance before astronauts even arrive. These robotic systems are designed to build landing pads, assemble habitat structures, and prepare energy networks using local materials such as lunar soil. Artificial intelligence plays a key role in managing these operations by making real-time decisions without waiting for instructions from Earth, where communication delays can slow down responses. In 2026, many experimental missions are expected to test how well these autonomous systems perform in real lunar conditions. If successful, they will prove that large-scale construction beyond Earth is possible without constant human control. This would dramatically reduce risk and increase efficiency for future missions. It also represents a major shift in space exploration strategy, where machines become the first builders and humans arrive later to expand and live in already prepared environments on the moon. Advanced technology enabling survival robotics, AI, and autonomous construction are making it possible to build and manage lunar bases before humans even arrive. 2026 is also significant because of the intense global participation in lunar exploration, where multiple countries and private companies are actively working toward the moon at the same time. Unlike earlier eras, when space exploration was dominated by a few major space agencies, the current lunar race includes a wide range of international players, each contributing new technologies, missions, and strategies. This has created a highly competitive yet collaborative environment, where progress is happening faster than ever before. Governments are planning scientific missions, while private companies are focusing on landing systems, transport services, and future commercial opportunities. As a result, the moon is becoming a shared target for both scientific discovery and economic development. In 2026, overlapping missions are expected to test landing techniques, communication, systems, and surface operations, all of which will determine who leads the next phase of space exploration. This competition is pushing innovation at an accelerated rate as every organization tries to achieve safer landings, longer mission durations, and more efficient technologies. At the same time, there is growing cooperation in data, sharing, and joint research, especially in areas like lunar mapping and resource identification. This blend of rivalry and collaboration is turning the moon into a global frontier, where the outcomes of 2026 could shape international space leadership for decades to come. Global competition and scientific discovery, multiple countries and private companies are racing toward the moon, while missions aim to unlock key insights about the solar system's origin and Earth's history. Beyond technology and competition, 2026 is also important because it reflects a deep psychological and cultural shift in how humanity views space and its future. For many years, space exploration was seen as something distant, heroic, and almost impossible for ordinary people to relate to. The moon was a symbol of dreams rather than a practical destination. However, with rapid advancements in reusable rockets improved landing systems, and continuous mission planning, this perception is changing quickly. In 2026, the idea of going to the moon is no longer limited to imagination or historical achievements, but is becoming part of realistic long-term planning. This shift is powerful because it changes how societies think about human limits and future possibilities. Education, media, and global discussions are increasingly focused on living beyond Earth rather than just exploring it briefly. Young generations are growing up in a time where lunar bases, space travel, and off-world resources are part of normal conversation. This mental transformation is just as important as any scientific breakthrough, because progress in space depends on belief as much as technology. When people begin to accept space as a place to live and work, not just visit, it opens the door to permanent expansion. In this way, 2026 becomes a symbolic gateway into a new era of human identity and ambition.